Yeah, so we're going to talk about Bronsted-Lowry acids and bases and proton transfer reactions. So remember when we have an Arrhenius acid or base, so Arrhenius, he said that acids have that H plus ion, so they start with an H, and bases have that OH minus ion, so they end with an OH. And that's a really simple model of acids and bases. And the problem is not everything fits into that. We saw this base NH3, that's ammonia, and it doesn't have an H plus ion, and it also doesn't have a hydroxide anion, so it just doesn't fit the model. So we're going to need a different model, a slightly more complicated model to deal with NH3. And that's the Bronsted-Lowry acid-base model. So I'm actually going to start with an acid, and then we'll get to the base. Let's try that again. So with the Bronsted-Lowry acid, they are proton or H plus donors. So they're going to give a proton to the water. So like if I have HCl plus water, it's going to donate a hydrogen to the water. So that means it becomes Cl minus. See how it was neutral, but it lost an H and a plus, so it becomes negative, Cl minus. Then my water gains an H, so it becomes H3O, but it also gained a plus because it's H plus. So now it's H3O plus. Remember that this is called the conjugate base. And this ion here is called hydronium. There's a Y there. So when we add an acid to water, it produces the conjugate base, it donates a proton, produces the conjugate base, and hydronium. So bases do the opposite. They're proton acceptors. And I use the word proton and hydrogen plus interchangeably because an H plus ion is just a single proton. They're the same thing. So let's say I've got that NH3, the one that was kind of the problem. I'm going to add it to H2O. Now that proton transfer is going in the other direction. The base is going to accept the proton. So the water is going to give it. So the water is actually acting like an acid here, and the base is going to accept that proton. So it's going to become NH4 plus because it gained an H and also gained a positive charge. And that means the water, it loses an H and a plus, becomes OH minus or hydroxide. We've seen that ion before. Hydroxide. And you guessed it, this ammonium would then be called the conjugate acid. So you'll always be told whether it's an acid or a base, so you'll know whether you need what direction the proton transfer goes. But just remember, it's always 1 H plus if it's an acid is donated, and if it's a base is accepted. So acids produce hydronium and bases produce hydroxide.